Yeah, hello students. It is nice to again meet you. We are doing the numericals of work, energy and power. Already we finished some of the example questions. I gave some example questions as homework also. Hope it was easy. Hope you were able to finish and complete all the numericals. Numericals has its own advantages as well as some constraints. When you see the advantages, you are thinking in an analytical manner. Though it is tough to think numericals, but it is pretty interesting to see how the numerical works. Look at the situation itself. There is a spring and there is a pulley and there is a block which is sliding. What will happen if the block is sliding like this? It will just go down. What happens when it goes down? The spring will be stretched. So when the spring stretches, then there is a potential energy of the spring and there is a stretching which is happening because there is a block is sliding down. So it's quite an interesting phenomenon. So you need to see it in that point of view, otherwise it will become quite tough and difficult for you. So take the numericals in a positive sense. Don't think, oh, this is something I need to really push myself to do it. Anything which you feel it as a burden to do it, it will be hard. Take it in a positive manner, try yourself, you will be able to succeed as a winner. So let us go to question number 32 in page number 363, right? So this is a very important and interesting numerical. A 1 kg block situated on a rough inclined plane is connected to a spring of a spring constant 100 Newton per meter as shown. The block is released from rest with a spring in the unstretched position. The block moves down 10 centimeters down the inclined plane before coming to rest. Find the coefficient of friction. It is asked coefficient of friction. There is a friction is also involved here between the block and the inclined plane. Assume that the spring has negligible mass and the pulley is frictionless. So I am bringing the same diagram in a format of diagram here. Please draw this diagram. So you know already whenever the block slides down an inclined plane, you have the mg acting downwards, you have the r acting in this direction, mg's cos theta will be acting in opposite to the normal reaction, mg sin theta acts downwards because this body is heading this direction, finally it stops, right? So the parameters which is given here is mass of the block is 1 kg and spring constant K is going to be equal to 100 Newton per meter. What else is given here? The distance moved is 10 centimeter. These are the basic parameters given here. Theta is going to be equal to 37 degrees. Okay. So sin theta, sin 37 is equal to, so next one is cos 37 equal to, it is already given here in the question itself. Sin 37 is going to be equal to 3 by 5. Cos 37 is going to be equal to 4 by 5. So these are all valuable parameters. So you hope you would have written this one. Now let us see how it works. So potential energy of the spring in the stretched position half kx square. That is the stretched position here. The next one is work done in the block to move down. So the block is moving down. When it moves down, what happens here? This is going down here, mg sin theta, and the frictional force is acting opposite in direction. So what happens here? Mg sin theta minus the frictional force into the distance. Force into distance. Hope you have understood the work done on the block, which is equal to mg sin theta minus, what is frictional force? It is going to be equal to mu into r times of x. So mg sin theta minus mu into what is r? mg cos theta into the value of x. That is work done. Till this much I think you will be able to easily understand, because this work done is very, very familiar for us. So it is the downward force minus the frictional force, all the things it is quite familiar for you. This is equation number 1. This is equation number 2. The potential energy of the spring is equal to the work done on the block. So whatever it is lying down, that is stored as a potential energy here. If it slides down, it is stored as a potential energy here. So you need to write down, what is you need to write down? So write down as, so potential energy of a spring is equal to work done on the block. Half k x square is equal to mg sin theta minus mu mg cos theta into x. What we are heading on, where we are heading on, what is the thing you need to find out? Everything is given here except the value of mu. You need to find out the mu. So in this one, mu is equal to question mark. Coefficient of friction is question mark. All things are given here actually. Every parameter is given here. So how do you head on now? Head on is this one and this one, it can cancel out. Because the extension of the distance it is moved, it is equal to the extension of the spring also. So keep this one, take this one here and bring this one here, this side. So it becomes mu mg cos theta is equal to mg sin theta minus, this one goes there, half kx. X square is not there, this x and x gets got cancelled out. Now mu here, keep here itself, it is mg sin theta minus half kx upon mg cos theta. Now put everything inside. This is 1 kg, and what is the value of g is given here as 10. Take g as 10. Sin theta is, sin 37 is 3 by 5 minus half into k is 100 and x is 10 centimeter, 0.1 divided by, again mass is 1 kg, g is 10, this one I am talking about, cos 37 is 4 by 5. Right, every parameter we have been able to do. So this one gets cancelled, you get 2 here, so it is 6 minus, here it gets cancelled, here it's 50, 50 into 0.1 is 5 divided by, this one gets cancelled, this is 2 here, and what is the down here? 8. What a simple thing, 1 by 8. And what's the 1 by 8 value? 0.125. Done. Very, very simple calculation. The calculation looks quite complex, but it is very, very simple. That's what mu is. Okay, hope you got this. The formula, finally derivation looks quite lengthy, but look at the numerical part of it. It is very, very simple. Straight you get the answer here. Alright, we'll go to the next question now. We are going to the exercise questions. So turn to page number 384. We'll start with question number 16. Question number 16 is a homework for you. Take a look on this question. A spring requires 4 joules of work to be stretched through 10 centimeters. Right? So work done is given here, 4 joules, and then it is stretched for 10 centimeters. Work done is going to be equal to kinetic energy. It is going to be kinetic energy is going to be equal to, it's given here, and then x is given here. Find the spring constant. What formula you will put? Kinetic energy of the spring or potential energy of the spring. You can say potential energy, not kinetic energy, potential energy. So half kx square is equal to 4 joules. K you need to find out, x is given here. Go ahead, do it. Okay. Question number 17. 17 is quite an interesting question. Please take a look properly. Draw this diagram. Question number 17. So there is a pan here and there is a spring here, so which is attached here to the support. So a ball is now dropped down. It's coming and falling here. That is a height h here. As it goes down, this will immediately compress. As it compresses, you will find this compresses for a distance x here. So this span is going to come down to this position. So this is going to be the new position of the pan, right? So look at the question here. A block of mass 2 kg is dropped from a height 40 centimeter on a spring whose force constant is 1960 Newton per meter. What will be the maximum distance x of the compression of the spring? How much this will compress? Alright, so write the basic quantities. Mass is going to be equal to 2 kilograms, and then height is going to be equal to 0.4 meters. Okay, I'm writing in terms of centimeters meters, and then the spring constant is 1960 Newton per meter. Alright, so G is going to be equal to 9.8 is given here. Now how it will happen here is, when the spring is now totally compressed, the new compressed position, then that time what will be the potential energy? That is going to be equal to half k x square. So in that compressed position, when the span has already come here, what will be the drop here? From here to here, it is going to be equal to mg into h plus x. That is the potential energy of the body which is coming down till this position. The body will be here, h plus x. That is going to be equal to the potential energy stored in the spring. It is just not mgh. Please don't consider only mgh. You need to put mgh plus x. That's very, very important. So you can write down potential energy of the spring when it's compressed, half kx square. The next one is potential energy of the block dropped is equal to, what is that? Is equal to mg h plus x. So mg h plus x is equal to half k x square. Right. Now what is something which is asked here? The one which is asked is x. We need to find out. Sorry, what will be the maximum distance x? Yeah, now not this. You need to find out x is going to be equal to question mark, right? So how would you go about now? You got to just substitute the values. Now what is mg? 2 into 9.8 into 0.4 plus x is equal to half into 960 into x square. Here also x square, this is also x here. Okay, now these two things you bring it down. Let's see how it works. Okay, 0.4 plus x equal to 1 by 4. This 2 has come down, so it has become 1 by 4, 1960 upon 9.8 into x square. Or maybe what you do is you multiply these two things, it becomes 19.6, right? This 19.6 you bring it down, so it is just 2 itself, it is 19.6. So this one 19.6 and this one gets cancelled. So what do you get here? You get 100 here, right? 1960 divided by 19.6, you get 100 here, and then 2 is still remaining here. So this also will get cancelled out, it is going to be 50 here then, right? So it becomes a quadratic equation. 50x square minus, so this all things goes up, minus x minus 0.4 is equal to 0. So now you are left out with the whole quadratic equation. So you are going to do it yourself. I'm just going to leave it here. Please go ahead and find out the value of x. Alright. So maybe you can try putting the value. So whatever the value it is there, or maybe you can multiply it by 0.2 anything and then try to do it. Okay, so we'll go to the next question. Question number 18. A solid of mass 2 kg moving with the velocity of 10 meter per second strikes an ideal weightless spring and produces a compression of 25 centimeter. So maybe a solid is moving and it strikes a spring. Alright, so the spring is now already attached here. So the spring is now going inside of how much? 25 centimeter. So it's going to be 25 centimeter, it was inside. So that's the thing which is given here. So it has a kinetic energy half mv square and it presses inside. Whatever the kinetic energy is implying, that much potential energy it will be compressed. So half mv square is going to be equal to half kx square of the spring. This is of the spring. This is of the body which is moving and hitting here. Right. So we need to find out things. What are the parameters which is given here? Look at the parameters. So m is going to be equal to 2 kgs and then velocity is going to be equal to 10 meter per second and x is going to be equal to 0.25 meters. So all things are given here. Now what you need to find out? K is going to be equal to question mark. So mass is given, everything is given here. So kinetic energy is equal to potential energy. Can you find out this one? You need to cancel this one and then find out. I'm just giving it to you. Please do this one. Yes, next one is question number 19. A bullet of mass 20 grams strikes a block of mass 980 grams. This bullet is coming and striking this one with a velocity v. This is the velocity of this one and is embedded in it. It just goes and buries inside. The block is in contact with the spring with a force constant 100 Newton meter. After the collision, the spring is compressed. Obviously, the collision is so high and it's going to compress itself. Compresses up to 10 centimeter. Now there are three questions are asked. First one is velocity of the block after the collision. In what velocity after the collision the block will move inside. Next one is velocity of the block. So that's our first one is the magnitude of the velocity of the bullet. So what is the velocity in which comes in hits. Next one is loss of kinetic energy due to the collision. So lots of other things it is given here. So let us look at the same thing. Block comes and hits here. Mass is going to be equal to 20 grams and then capital M is going to be equal to, this is capital M and this is small m. What is capital M here? That is 980 grams. So small m plus capital M is equal to 20 plus 980 is going to be equal to 1000 grams. That is going to be equal to 1 kg. Right. And the block is heading on with the spring constant 100 Newton per meter. So velocity is question mark. Okay. So this v is the velocity of this one, and when this one moves, it moves the velocity of v dash. This block when it moves. Okay. So that's the way which happens here. So how much distance did it move inside? It moved for a distance of 10 centimeter, and x is going to be equal to 10 centimeter. So the first thing is kinetic energy of this one is equal to potential energy of the spring. As soon as it is buried inside, the total mass is the one which you need to consider. It is going to be potential energy. So there is a part of the question here. So kinetic energy of the block is going to be equal to potential energy of spring. Half k x square is going to be equal to half m v dash square. V dash is total mass, how much it moves. So it's going to be equal to half into 1 kg. This is 1 kg. V dash square is going to be equal to half into 100 into 0.1 the whole square. What is 0.1? It is here. 10 centimeters, so it's going to be 0.1. Half gets cancelled out. So it's V1 square. This 100 into 0.1 it will become 1 itself. Because it's 0.1, it will become 0.01 into 100 it will become 1. So V1 is going to be equal to 1 meter per second. That's the velocity in which it moves. Right? So there's A part is answered here. Velocity of the block is found out. B part. The B part of the question is, now we are doing question number 19. Right? B part of the question is, magnitude of the velocity of the bullet. Now how do you find out this one? Moment, you need to conserve the momentum. Momentum conservation you need to do. Right? So once we do the momentum conservation, you'll be able to do this one clearly. So let's do this one. M into V is going to be equal to M dash into V dash. That's what the momentum conservation is. So what is small m? It is 20 grams. Into velocity we don't know. What is m dash fully? It is 10,000 grams. Into V dash is just now found out. It is 1. So we can easily find out. So gram it gets cancelled out. So don't worry about it. You can just put this way itself. So what is V is going to be equal to 100 upon 2. So it's going to be equal to 50 meter per second. So V is going to be equal to 50 meter per second. C part of the question is loss in kinetic energy due to collision. How much kinetic energy this is lost? Quite simple. Velocity is already given here. V1 is already given here, and V2 also, the capital V is already given here. Maybe I can say V dash. So yeah, this is the V. This is the bullet velocity. So loss in kinetic energy is going to be equal to half mv square. What is this one? It is bullet minus half m dash v dash square. What is this one? This is of the block. So half into mass of the bullet is how much? It is 0.02 into velocity. What is the velocity of the bullet? It is 50 the whole square minus half into what is m dash? That is 1 kg, and what is v dash? That's also 1. So these two gets cancelled out. So it's going to be 0.01 into 2500. So what this will become? 2500 means it will become only 25 minus 0.5. So it's going to be 25 minus 0.5. It's going to be equal to 24.5 joules. That is a loss. What is asked here? Loss in kinetic energy only we found out. What is asked? Loss in kinetic energy due to collision. It's 25.5. Okay, that's what it is. A good question. Please make sure you remember everything. Question number 20. This is a very interesting question. Please draw this diagram in your notebook. 20 meters, 10 meters, 3 meters. I am just explaining. You have to do it yourself. Okay. A smooth sphere, mass 10 kg. 10 kg. Okay, quite a big one. 10 kg is quite a big one. Rolls on a smooth curved surface from a point A with a speed of 10 meter per second. So the V is going to be equal to 10 meter per second. The sphere reaches the point D passing through B. Okay, it reaches here, passing through B and passing through C. It finally reaches here. Right. So find total energy of the sphere at A. What is the total energy? Total energy at A, it's going to be equal to kinetic energy plus potential energy. What is the kinetic energy? Already it is having a mass and a velocity here, that is half m v square plus m into g into h. That is total energy at A. This is the A part. So you need to do it together. Half into 10 into 10 square plus 10 kg is the mass, and g is going to be equal to 10 is given here, that's also 10, and what is the height here? 20 meters. So you will get a total answer, total energy, you will get an answer. So do this one, be part of it. That much of total energy, okay, now it is coming down so fast and it is coming to reaching here. The total energy of this one will be equal to the energy which is possessed here as a kinetic energy down here. So it is asked here, B, kinetic energy and the potential energy at B. What is the potential energy at B? Potential energy is 0. What is the kinetic energy? This total energy is transferred to the kinetic energy here. So you can write easily. The next one is the kinetic energy at C. So from here, whatever the total energy, the kinetic energy it had, that is going to go here, up here. Alright, how will you find out the kinetic energy here? That means there is a potential energy here. So potential energy and then kinetic energy. The potential energy plus kinetic energy at this point is equal to the kinetic energy here, or the total energy here. So this total energy which is here at B is equal to kinetic energy at this point plus potential energy at this point, which is 10 meter above. So when you calculate this one, you will be able to find out the kinetic energy alone here. That's what it is asked. Kinetic energy at C. Then it slides down. When it's sliding down, it is already above a height here. Alright. So this total energy, which is equal to, and it slides down, and you can find out the value here also. So I am just leaving it to you. Please try it. It is quite interesting question. Okay. Now we'll go to the next question here. The next question here is question number 21. So the question number 21 also, it talks about, this is question number 20. Now we are going to start with question number 21. A ball is rolling to and fro on a smooth circular cup as shown in the figure. Okay, the lowermost point is A. So, and the height is 10 centimeter above the height. What is the speed of the ball at A? So what happens here is, this place it is having a kind of potential energy. Alright, there is a height which is gone here. There's a height which is gone here. Is a potential energy. Potential energy is going to be equal to, maybe you can call it as B height. Potential energy at B is going to be equal to kinetic energy at A. Whatever the potential energy this body had, the same thing it will transform into kinetic energy here. So mgh is going to be equal to half mv square, the kinetic energy here. Mass gets cancelled out. So what is v square is going to be equal to 2gh, and v is going to be equal to under root 2gh. So we need to find out the v value. Quite easy now. 2 into g is 9.8 into height is already given here is 10 centimeter, because from here to here it is 10 centimeter. It is just 10 centimeter here. Or it is going to be equal to 0.1 under root. You do this value, you will get this. So it's going to be 19.6 into 0.1 under root. So once you do this value, you will get maybe 1.4 or yes, it is 14.4. Yeah, 1.4. It is given here as 2.8. Yeah. So answer is 2.8. So sorry, 1.4. 1.4 is correct. So it is going to be 1.4 meter per second. Next one, question number 22. Simple. Similarly, same thing. So this one, a smooth body is released from rest A. From here it comes down. That means it is already at rest. So it's not moving. So it's just potential energy here. M into G into H. Right? So it says in the top, and 40 centimeter above. What is the speed of the body at the bottommost point? So it is mgh is going to be equal to half mv square. Speed only it is asked. Speed at the bottommost point. So it's 22. Mass gets cancelled out. So v square is going to be equal to 2gh. So v is going to be equal to under root 2gh. Same thing only. Whatever we saw in the previous question also the same thing. From here it's coming down. Similarly it is going to be the same. So it is going to be 2 into 9.8 into height is 0.4. That is the value of v. So it is going to be equal to 19.6 into 0.4. So you get here as 1.4 into 0.2. So it's going to be equal to 2.8 meter per second. That will be the value here. Yes, 2.8. The next part is quite interesting here. How far along the adjoining smooth inclined plane will the body go? How much it will go up here? You got this value velocity here. So half mv square at the bottom of this one is going to be equal to the distance, how far it moves. It just goes for some distance here. The block goes till this point. How far it goes? We know already what is the way. The way in which it goes is, what is the force which is going to be there? Downward forces. The force is mg sin theta. Please remember, this is mg sin theta when it goes down. So it is going to be equal to mg sin theta. That is the force, and there's a distance here. The potential energy, kinetic energy, is going to be equal to work done. This is the basic thing. So this is the parameter in which it works. Now substitute everything. Mass gets cancelled out. Right? What it is asked? Distance only it is asked. So it's going to be v square is going to be equal to v square upon 2g sin theta. It's going to be equal to x. How far is asked? That's what it is. You need to find it out. So once it is v square is going to be equal to 2 into 9.8 into 0.4. Now what is the v square I am taking is, I am taking this v square from this point. V square is equal to 2gh. 2 into g into 0.4. So the same thing I am taking it out. So this is also 2 into 9.8 into sine 30. It's going to be x. This one gets cancelled. So remember, v square is the 2.8 only. 2.8 square I need to put. I can put this also, no problem. 2.8 the whole square you put, no problem. Or otherwise, 2gh is already there. This entire part is again I am putting, so that cancellation is quite easy here. So what will be the value here? 0.4 upon 1 by 2 is equal to x. So x is going to be equal to 0.8 meters. Okay, what is the answer here? Yes, 80 centimeter. 0.8 meters. This is homework for you. I'll read it for you. An automobile moving at a speed of 72 kilometers per hour, that means 20 meters per second, reaches the foot of the smooth inclined plane. The inclined plane is here like this. An automobile is moving, maybe a car or something. It is, so the car or something, it is just coming here and it is reaching here. So this is going in 20 meters per second. And it is going to be theta here. So when the engine is switched off, you know how much distance the automobile goes up the inclined plane before stopping. So this is 30 degrees here. This 30 degrees is going to be here. So how much distance the same automobile will go? So this distance is asked. Half mv square is going to be equal to mg sin theta into x. Same thing whatever we found out, you need to find out the x value. Quite simple. Okay. Question number 24. So that will be my last question. Then I will give everything as a homework for you. Please do it yourself. This also I will try to just give it to you. You need to just do it. Question number 24. A length of a simple pendulum is 1 meter. So this is a simple pendulum. It is a 1 meter long pendulum here. This is 1 meter. And the mass is 0.1. So M is going to be equal to 0.01 kg. The bob is taken towards one side until the thread becomes horizontal. So that means the bob is come like this. Okay, this is 1 meter. So when you leave it, it will take this path and then come to this place. So the bob is taken towards this one and becomes horizontal, and then calculate the kinetic energy when the bob and the thread of an angle is 0 degrees, 30 degrees with the vertical, right? So when it comes straight, when it's left here, it comes straight. This is 90 degrees here, 90 degrees. When it will become 0 degrees, it comes straight to this point. What is the kinetic energy at this point? What is the kinetic energy at this point? What is kinetic energy? The potential energy is going to be equal to the kinetic energy here. What is the potential energy? 1 meter is the potential energy here. M into G into H. So that will become kinetic energy. That's quite simple. You can do it. Okay. Whatever mgh you find out, that's equal to kinetic energy. Now, what is that next one is they are saying at 30 degrees with a vertical. So when it is 30 degrees with a vertical, what will be the kinetic energy? What will be the energy here? Kinetic energy here. So what do we need to find out? There is a height which is already raised here. So this is the height. So find out what height is going to be this much, because this is going to be raised here. So you need to find out from 1 meter what is the value which is raised, right? So you need to find out from this value here. How to find out this value? You need to find out this part of it. This part of it you find out, and then subtract it by 1 meter. Okay, then that much is the height. If you find out, this is the x you find out here. So that is going to be the mgh, and it's going to come and fall here. You will be able to find out. Okay, so please do that. Next question, question number 25. Please do this as a homework. 25 is homework, 26 homework, 27 is homework, and 28 homework. Try yourself. The momentum of a body is increased by 50%. What will be the percentage of increase of kinetic energy? Try this one. A body of 1 kg falls freely under gravity. Find its momentum and kinetic energy 5 seconds after it starts falling down. So it's also momentum and kinetic energy relationship. Please do this one. And also these are all this momentum kinetic energy things. Okay, try this one. So hope you got clarified about many things here. Alright children, thank you so much.